Hello, I'm Brian Hageman, CEO of Deluge Technologies, and I prepared this presentation for the Board of Directors at the Water Infrastructure Finance Authority of Arizona. I'll be talking today to you about desalination in Arizona of brackish water that's currently here in the state, using 100% renewable sustainable energy. I'm an inventor. I invented the hydraulic engine technology that I'll be presenting here, and I've had an entrepreneurial spirit since I was very young. Part of my job is to provide a vision using my technology and what it can do to provide solutions. The issue that we're looking at here is a new source of water for Arizona. The United States Geological Society has provided me with the data points in Maricopa County for over 2,500 wells and their chemical content, and over 2,000, two-thirds of them are unusable because the salinity levels are too high. So my solution with the technology we have at Deluge is to desalinate the brackish groundwater using renewable sources. Brackish water in Arizona, it's a critical resource, and we've been discussing it for many years. The Montgomery and Associates engineering company in Arizona identified more than 600 million acre feet of recoverable brackish groundwater in storage right now. That's almost 100 times the current total Arizona water use. That means we have a 100-year water supply of brackish water in Arizona that's not being used yet. Out of the 600 million acre feet of brackish water in Arizona, 200 million acre feet of brackish water is available right here in Maricopa County and Pinal counties. So it is a resource that can be tapped into. I'd like to talk to you about that today. The science of groundwater has been studied for a long time. Recently from physics.org, they've had scientists discover that groundwater replenishes itself much faster than scientists previously thought. The surface water that we see on the surface doesn't just disappear. Some of it evaporates, but most of it goes underground. And we haven't been exactly sure how those aquifers work. And like we said here, groundwater replenishes itself possibly faster than originally thought, according to physics.org. We need to maximize the use of Arizona groundwater before importing from Mexico. It looks a lot like salt water from Mexico would be the next source of water because we can see it. We can see it. It's above ground. All the water that's below ground can be used, and we need to maximize the use of Arizona groundwater. If we ever do bring water from Mexico to Phoenix, we want to do it with my technology in the way I proposed back in 2004. I was in a report written by the Arizona Department of Commerce back then, and I suggested a system that would take salt water from the Gulf of California, Sea Cortez, and pipeline salt water up to Yuma. So we'd be buying salt water from Mexico and bringing it up to a new desalination plant in Yuma. I wanted to have the desalination plant in Yuma instead of Mexico because this way it'd become an asset within our state boundaries and reporting to the state and paying taxes to the state. From that Yuma desalination plant, we would be sending pipeline clean water up to the CAP that would be delivered to Phoenix and Tucson. But keeping the desalination plant in Arizona, I think, is a very important part of the bringing, using the salt water from the Sea of Cortez. Brackish water desalination by Deluge Technologies will convert over 99% of the water into usable drinking water for our cities. That leftover brine mud that's left over is actually converted into thermal storage blocks that we'll be using in the future for future projects, creating a zero liquid discharge desalination system. The hydraulic engine technology plugs right into existing technologies very easily. We provide a shaft power, and from our engine, we actually produce 4 times more torque than a comparable horsepower engine using gasoline internal combustion. But our shaft power is hooked up through shaft coupling to an RO pump or an electric generator or anything else that needs a shaft that usually comes from an electric motor or gas engine. Our hydraulic engine provides a new way to turn those mechanical pieces of equipment. In this case, a high pressure RO pump or water conveyance pumps for sending water down pipelines. And our system can be run 100% from the solar thermal energy from the sun and completely independent from the electrical grid if we wanted to. Our desalination system uses both reverse osmosis desalination and distillation desalination. We take the brine stream from the RO that would normally be reject, we feed that into a steam column using 1,000-degree hot air. We have solar thermal dish collectors that collect the heat and make hot air. And that hot air is mixed with the water, the heavy salt water, and it's turned into steam. The steam goes into a condenser and that makes distilled water. That makes up the rest of the 99.9% of new clean water from that brackish water. We use that salt reject and we have salt removal pumps on the bottom of the steam column. That goes into a mixer, kind of a mud salt mix it with earth and cement and make my adobe salt thermal blocks that are used for 24-hour heat storage. We use the solar thermal dish collector like we do with desalination, the distillation method, and make hot air. This 1,000-degree hot air from our solar thermal dish collectors is injected into our thermal bricks, thermal blocks that are underground in a big oven. Basically, it's a swimming pool type design construction with a top on it, like an oven top. And we pump 1,000-degree hot air into the thermal blocks that heat up. Then we extract that hot air off of the same oven into our heat exchanger that makes hot water, 180-degree Fahrenheit hot water for our hydraulic engines. So this is a solar thermal storage collection battery that will allow us to operate 24 hours a day. Our 3 contract manufacturers are ready to start on this project in Arizona on the phase 1, 2, and 3 phases that we have ready to go. The manufacturers are right here in Chandler, Phoenix, and Tempe. They will build the component parts to each one of these phases. The phase 3 project will desalinate 1,095 acre-feet per year, and the system's flexible and scalable to any required capacity. We'll probably be having 5 of these phase 3 projects in each location, around 20 different locations around the county. What comes out of each phase 3 project is electricity, clean water, and hydrogen. Desalinated water is our primary goal, but these will be designed for working to full capacity in January. And then in July, we'll have a lot of excess fuel from the sun that we'll be able to run our systems faster, producing more desalinated water, and the extra water and electricity that we'll be generating will go through a hydrogen electrolysis process to make hydrogen for sale also. Our 5-year plan for building out these phase 3 projects we'll do 100,000 acre-feet of brackish water desalination in Arizona, right here in Maricopa County. The total cost of construction is $250 million. And we'd like to get started with the phase 1, phase 2, and phase 3 with our manufacturers that are ready to go using grant funding. We've had a lot of private investment bring us to this point, but we think it's time that the state of Arizona invests in their future by granting us some money through WIFA in the early stages. And then the majority of our projects will go through the traditional WIFA financing as soon as we're selling water and become a private water company registered with the Arizona Corporation Commission. The price of water in Arizona, the price that we plan to charge from our desalination plants, is based on CAGRD rates that they currently have. CAP, the Central Arizona Project, pumps water into the groundwater, and it goes into a bank, water bank, and then when customers use that water, it's right now costs $765 per acre foot. I plan to use that as a benchmark, and 80% of the CAGRD rate is our $612 per acre foot for wholesale deluge water prices that we'll be using. You can see in down the column there, then 2028, the CAGRD rate goes up to about 850. That'll bring our deluge water up to about $650. I was very proud last summer to get my contractor's license in Arizona from the Arizona Register of Contractors. And my engineering contractor's license allows me to build, besides freeways, bridges, and tunnels, I can build water infrastructure projects, electricity generation projects, hydrogen, and we do well drilling. We'll be doing all our own well drilling out of the Hageman Power Company that's been assigned the contractor's license. So Hageman Power Company will be the build part of build, own, operate, with Deluge Technologies will be the owner-operator of all the facilities, doing the day-to-day operations of the facilities and selling the water. We plan to operate the systems for about 10 years and then sell the systems off as kind of an exit strategy. In 10 years, selling the facilities to political subdivisions and other private water companies in Arizona. Turning a vision into reality takes money, manpower, and materials, and I can build anything. With my experience from building huge refineries in Indonesia on top of rice paddies, and then giant oil petrochemical facilities in Saudi Arabia in the middle of the desert, and then back here in Arizona building nuclear power plants in the middle of the desert, I can build just about anything mechanical engineering wise, and desalination is a great goal for our first facilities here with Deluge Technologies in Arizona. I look forward to working with WIFA over the next 10 years, or at least the first 5 years of our 5-year plan. And then in the future, we'd like to expand out from Maricopa County into Pinell counties and Yuma County for sure to continue the phase 3 type projects for use in all parts of Arizona. Thank you very much, and I look forward to working with all of you in the future.